Next one we want to consider is a post increment. So post increment plus plus operator. So these are pre-increment. The difference is as follows. So if I use an integer as an example, suppose if I have int n is 2, and then if I do y is n plus plus, then what you get is at this moment y gets 2, and then after that yn becomes 3. So the post increment. Post means do the operation for n first. So here n is going to be used for y as an assignment. So do assignment first. So y gets 2, and then n is incremented. So when we implement post increment operator overloading, what we need to do is as follows. So let's create a fraction number again. Now we have y is 2 over 5 is there, and then fraction z, let's define then z is y plus plus. Then what we are expecting now is if I do now k is y, then at that moment y is incremented, so z gets incremented the value of y, but z gets prior to the increment. So 2 over 5 z will get. So z is 2 over 5. However, at this moment, k is 7 over 5. Now, once this statement is done, y is incremented. So k will get 7 over 5. So let's implement post increment. So when you define operator overloading, return value is a fraction and the operator is a plus plus. And then if I do this way, nothing on the right hand side of the operator, so parameter is empty, then pre-increment and post-increment are the same. So we use a special syntax. Just give integer and then don't use the parameter at all, then that is a post-increment for the compiler. So if you give an argument, a parameter, then that is interpreted as a post increment instead of a pre-increment. But we don't need to use the parameter at all though. So fraction operator plus plus, but int unused. We never use that. Then this is definition for post increment definition. So post increment, we need to return the current value. As I explained here, post increment means z should get y prior to the increment. So we need to keep a copy of the current value. So let's create a clone copy of the current value with a numerator and denominator. We can just create a copy of the current value. Copy of the current value. Then we just do increment as we did in pre-increment. So we do exactly the same way, the formula. That's just what we need to do. Then what you need to return is the copy prior to the increment. So that is a post-increment operation. So let's test it. Compile the program, stop the debuggers. It is already running. Now start the debugger after compilation. It's there. Let me do step over here. At this moment, y is 2 over 5, z is 1 over 1. Now we do post increment. Step over, z gets 2 over 5, which was the original y value. Now y is incremented, so y is 7 over 5 this moment. So that's the post increment. So let me stop the debugger and let's do exactly the same thing for post decrement. In post decrement, we are going to test something like this. Now let's do z is y minus minus, and then let's do one more time y minus minus one more time. And then definition is there. Implementation will be similar to that fraction operator minus minus int unused. Then this is a post decrement. So we do exactly the same way post increment, but the actual operation is a minus equal. Other than that, it's pretty the same. Now compile the program. Let's change the breakpoint. Start debug. So at this moment, z is 2 over 5 and y is 7 over 5. So here we are about to execute this line. Z is 2 over 5, y is 7 over 5. Step over, z is 7 over 5 with the previous y value, and then y is decremented 2 over 5. So y is now 2 over 5. Step over, now z is 2 over 5, but y is minus 3 over 5. That's a post decrement operation.